Petrichor, why rain smells so good, the science explained. Welcome to FactSpark, where we ignite your curiosity with fascinating facts about the world around us. Today we're diving into a sensory mystery you've probably experienced countless times. Ah, that smell. You know the one. That incredible, earthy, fresh scent that fills the air right after a summer rain. It's almost magical, isn't it? It's a scent that evokes feelings of freshness, renewal, and a deep connection to nature. For many of us, it's one of the most comforting and universally loved aromas. Well, that magical scent actually has a name, and it's just as beautiful as the smell itself. Petrichor, coined in 1964 by two brilliant Australian scientists, Isabel Joy Baer and Richard Grenfell Thomas. The word petrichor comes from the Greek words petra, meaning stone, and ichor, which in Greek mythology refers to the golden fluid that flowed in the veins of the immortal gods. Talk about a fancy name for a dirt smell. It's a name that perfectly captures the elusive, almost divine quality of this natural perfume. But what is this immortal essence of stone made of? And how does rain, just plain water, conjure up such a delightful perfume? Is it just the water itself, or something more complex at play? Get ready, because we're about to dive deep into the fascinating, sometimes wild science behind why rain smells so good. We'll uncover the hidden processes and tiny players responsible for this incredible sensory experience. So petrichor is that distinctive, earthy, and usually pleasant odor that fills the air after rainfall, especially when it follows a warm, dry period. It's a smell that many people believe they can detect even before the rain, and there's some evidence to support that, as increasing humidity can start to release some of these compounds. It was in 1964, in an article for the prestigious journal Nature, that Australian CSIRO scientists Isabel Joy Baer and Richard Grenfell Thomas officially gave this unique smell its scientific name. Their groundbreaking research involved a rather clever method. They steam-distilled rocks that had been exposed to warm, dry conditions. What they found was a yellow-colored oil that had become trapped within the rocks and soil. They discovered this substance was primarily responsible for the distinctive smell. The source of this oil, they theorized, was a combination of volatile oils secreted by plants during dry weather, a natural signal to halt root growth and prevent seed germination, conserving precious water, and specific chemicals released by soil-dwelling bacteria. This early discovery revealed a crucial detail. The smell isn't actually created by the rain itself. Instead, the aromatic compounds responsible for petrichor are already present in the environment, accumulating during dry spells. The rain acts as a trigger, liberating these pre-existing elements. It's like nature has its own hidden perfume counter, just waiting for the right moment to spritz. Petrichor isn't just one smell. It's a symphony of natural compounds working together to create that signature aroma we all love. Think of it as nature's very own, incredibly complex perfume with a few surprising ingredients. The biggest star of the petrichor show is a compound called Geosmin, which, fittingly, literally means earth smell in Greek. This incredibly potent molecule is primarily produced by soil-dwelling bacteria, specifically from the genus Actinomycetes, like Streptomyces. These tiny, unfathomably concentrated bacteria are vital for decomposition and soil health, playing a crucial role in breaking down organic matter. During dry periods, they produce drought-tolerant spores. When rain finally arrives, these spores are launched into the air, carrying geosmin directly to our noses. And here's where it gets truly wild. The human nose is incredibly sensitive to geosmin. We can detect it at concentrations as low as 5 parts per trillion. To put that in perspective, that's like smelling 1 tiny teaspoon of water in 200 Olympic swimming pools. It's millions of times more potent than most other odors we can detect, even more sensitive than a shark smelling blood in water. So, next time you smell rain, give yourself a pat on the back. Your nose is a superhero. Next up are volatile plant oils. During dry weather, Many plants secrete these unique oils onto rocks and soil. These oils actually serve a purpose, helping to signal the plants to slow down growth and prevent seed germination, conserving precious water during drought conditions. When rain falls, these accumulated oils are dispersed into the air, adding a distinct, often sweet, musty, or green note to the overall Petrichor symphony. They are nature's subtle way of perfuming the landscape. Sometimes, especially after a powerful thunderstorm, you might also catch a clean, sharp, almost electric scent. That's often ozone, O3. Lightning's intense electrical charge can split oxygen gas, O2, into separate atoms, which then reform into ozone. Wind currents can carry this ozone down from the clouds directly to our noses, adding to the fresh post-storm aroma. The combination of geosmin from soil bacteria, volatile plant oils from vegetation, and occasionally ozone from atmospheric electricity creates this unique and complex aroma. This blend of origins reveals that petrichor is more than just a pleasant smell. It's a sensory manifestation of the intricate and dynamic interconnectedness of Earth's various systems, the geosphere, the biosphere, and the atmosphere. It's like the planet itself is breathing out a sigh of relief, and we get to enjoy the scent. For decades, scientists knew what caused the smell, but not exactly how it got into the air for us to enjoy. Then, in 2015, brilliant researchers at the Massachusetts Institute of Technology, MIT, finally cracked the case. They used high-speed cameras to observe raindrop impacts, revealing a mechanism previously undetected. They observed that when a raindrop hits a porous surface, like dry soil, sand, or even concrete, it traps tiny air bubbles at the point of contact. And just like the effervescent bubbles in a glass of champagne, these tiny air bubbles then shoot rapidly upward through the droplet. As these bubbles reach the surface of the raindrop, they burst with a fizz, releasing a cloud of microscopic particles called aerosols into the air. These aerosols are the tiny scent-carrying vehicles, picking up geosmin, plant oils, and even microscopic bacteria and spores from the soil, and launching them into the atmosphere where they can be carried by wind directly to our noses. This explains how these aromatic compounds previously trapped become airborne and detectable. The MIT team also found that the generation of these frenzied aerosols is greatest during light to moderate rainfall on porous surfaces like sandy or clay soils. During heavy rain, the drops hit too fast, repressing the creation of bubbles, and thus far less smell is released. This crucial observation explains why the smell is often strongest after a gentle shower, not a torrential downpour. It's like nature knows just how to deliver its best perfume, a gentle spritz, not a drenching. So we know what petrichor is and how it gets into the air, but why do humans and even some animals find it so incredibly appealing? Scientists believe our love for this smell might be deeply rooted in our evolutionary past, a fascinating story of survival and connection to nature. For our nomadic ancestors, finding water was paramount for survival in vast, often dry landscapes. The smell of petrichor, signaling recent rain, would have been a crucial indicator of nearby freshwater sources, fertile land ready for new vegetation, and an abundance of food, all vital for life and sustenance. This sensory cue provided invaluable information about the environment, directly impacting their ability to thrive. We're not alone in our sensitivity. Camels, for instance, are highly sensitive to geosmin, which helps them locate life-saving oases in the desert. Even tiny creatures like springtails play a role in benefit, as geosmin attracts certain insects which then spread the bacteria's spores around the planet. These little guys are like the bacteria's tiny travel agents. This natural dispersal process has been happening for over 400 million years, contributing to the smell's global prevalence. Throughout history, human cultures have relied heavily on rain for agriculture and survival. This deep, historical reliance may have hardwired us to associate the smell of petrichor with life, abundance, and relief after dry spells, creating a positive emotional response that continues to this day. It's like our brains give us a little happy chemical boost every time we smell rain, a primal reward for a good survival strategy. No wonder perfume manufacturers try to bottle it. So the next time you breathe in that incredible post-rain scent, take a moment to appreciate Petrichor, a complex, beautiful blend of bacterial geosmin, volatile plant oils, and sometimes atmospheric ozone, all launched into the air by the precise, tiny impacts of raindrops. It's a natural masterpiece, a scientific symphony playing right under your nose. It's a testament to the hidden wonders of our planet and the intricate connections that shape our sensory experiences. What's your favorite thing about the smell of rain? Let us know in the comments below. If you loved uncovering this scientific mystery, hit that like button, share this video with a friend, and don't forget to subscribe to FactSpark for more amazing facts about our incredible world.